Hey everybody, this video lesson is going to cover the drawing of Lewis dot structures. Now, basic Lewis dot structures can be drawn very simply by taking the elements and their valence electrons and connecting unpaired electrons. Let's take, for example, water. Alone, oxygen has 6 valence electrons, 2 top, 2 bottom, 1 left, 1 right. Each hydrogen comes with 1 valence electron, and if you simply take the dots that are unpaired and connect them, they become matched up. This is a simple way of doing Lewis dot structures. But this way limits us to which elements can be in the middle and which elements can be on the outside of a molecule. This is what I like to refer to as the connect the dots method. As I mentioned, this limits the number of pictures that you can draw. You can't really encompass all the molecules that are known by just simply connecting the dots. It also limits which element can be in the middle. In previous science courses, you were probably told that oxygen can only make 2 bonds because it only has 2 unpaired electrons. Or chlorine can only make 1 bond because it only has 1 unpaired electron. I need to let you know that that is entirely false. In fact, all elements can be in the middle with the exception of one element, and that's hydrogen. Hydrogen is always on the outside and can never be in the middle. But all elements may be in the middle of a molecule, no matter what it is, or how many valence electrons it has when it's all by itself. Furthermore, the bonding limit for each element is the same. All elements can make up to 4 bonds. No element is limited to 1 bond or 2 bonds, like in the case of chlorine or oxygen. All elements can make up to 4 bonds. So from this point forward, all elements can be in the middle of a molecule and can have up to 4 bonds. The more advanced method of drawing Lewis dot structures is what I refer to as the electron bank method. The electron bank method applies to all molecules and does not limit us to any type of molecule having a particular element in the middle. Any element can be in the middle. As long as you follow the method, you will get it correct 100% of the time. Now, the electron bank method is a series of 6 steps. I'm going to list the steps and draw a molecule as an example. I'm going to split my page down the middle so there's a line between the instructions and the example. Now, the only thing you'll be given is the chemical formula for the compound. In this example, it's going to be PCl3. Step number 1 is to find the valence electrons of that molecule, meaning take each element and add up the total valence electrons of the whole molecule. So over here on the right side, underneath the P and the Cl3, I'm going to write 5 for phosphorus, because phosphorus have 5 valence electrons, and 7 times 3 for chlorine, because there are 3 chlorines. Each chlorine has 7. If I add all these together, you get 26 total valence electrons. Now this number is my bank. My structure can't have any more or any less electrons than the electrons in the bank. I need to spend all the electrons out of the bank, and I can't have any left over. Step 2 says write the central atom out and connect it to the outside atoms using a single bond. In the molecule, the central atom is going to be the one you have the least amount of. So in this case, phosphorus is only 1, and chlorine is 3, so phosphorus will go in the middle. Now I did step 2 in red and matched it to the red writing so that you can easily see what the steps are and what part that translates to over here on the right hand side of the line. Step number 3 says subtract the electrons used up in bonds from the bank. There are 2 electrons per bond, so in this case, since I have 3 bonds to chlorine, I'm going to go back to the bank and subtract 6 electrons and see what that gives me. When I take 6 from 26, I have 20 left over. The 6 electrons are used up in the bonds, and their 20 remaining electrons are going to go around the molecule in red as electron dots. Now these get distributed in pairs, so essentially I have 20 dots or 10 pairs of electrons. Now step 4 says distribute the electrons as pairs around the drawing, starting with the outside atoms and working in. All the atoms max out at 8 electrons. You might run out before the middle atom gets 8, but that's okay. And so over here I'm going to put the electrons, 10 pairs of electrons, I'm going to start putting them in around the chlorine. As you can see, I put in electron dots around the chlorines. I have 6 around this chlorine, 6 around this chlorine, and finally 6 around this chlorine. That uses up 18 of my 20 dots. The remaining 2 dots will go on the inside atom. If I look closely, each chlorine has 6 dots and a pair connected to it, so that makes 8. This chlorine has 6 dots and a pair connected to it from the bond, so that makes 8. And same as this one, 6 dots and a pair connected from the bond to make 8. The remaining 2 electrons will go on the phosphorus. And so I place them on the top like this, and then I move on to step number 5. The last step is to check to make sure that each atom is surrounded by 8 valence electrons. Pay extra close attention to the middle atom. If there are short electrons, it will be on the central atom. So the chlorine over here, again, is surrounded by 6 dots and connected with a bond, so that's 8. 6 dots in a bond is 8, 6 dots in a bond is 8, and this phosphorus is connected by 3 bonds and 2 dots, so that's 8. If you're short, you would have to go on to step number 6. Step number 6 is only used if completely necessary. Let me scroll up to give myself a little bit more room. Now let's say you're looking at a molecule that's kind of like the one we were drawing up above, but after distributing all of your dots in step 4 and checking to make sure everything has 8 in step 5, you look at the central atom, atom X here, and it doesn't have 8 valence electrons. It's got 2, 4, 6, but it's missing a pair on the top. If that's the case, you need to proceed to step 6. Step 6 says borrow a pair of electrons from an outside atom to make a double or even triple bond in order to get the central atom to 8 electrons. And so what you can do is, I'm just going to choose this first chlorine because it's the closest, but take a pair of electrons and take it away as a pair and rewrite it as a bond between chlorine and X. See, what I did was eliminate a pair of electrons and turn it into a bond. Now, chlorine over here still has access to those 2 electrons. It's just now as a bond and not as a pair of electrons. Still has 2, 4, 6, 8. These chlorines remain untouched, but check out X in the middle. You now have 2, 4, 6, 8. So now everything has 8. Remember, you only do step 6 if the central atom doesn't have enough electrons to make 8. So the last thing I want to talk about in this video lesson is how to handle polyatomic ions. Remember, polyatomic ions are those things that are covalently bonded together but carry a charge. Now, how does that charge affect our picture? Well, I'm about to show you. Positive ions subtract electrons from the bank, and negative ions add electrons to the bank. So if you're drawing this Lewis dot structure for CO3-2, you start out in the first step by adding up all the valence electrons. Carbon is 4, each oxygen is 6 plus 6 plus 6, or 6 3 times, but the last thing you need to do is account for that -2 charge. And as we talked about, negative ions add electrons to the bank, and so all you do is simply add 2 to get your final number. And so I added 2 to get 24. Now I proceed drawing this molecule with this bank in mind, 24 electrons. I put carbon in the middle and connect it to single bonds to oxygen, and then I subtract those 6 electrons from the bank. 24 minus 6 makes 8. Now I know that I need 18. Now I know that I need 18 dots to be distributed around the oxygens first, and if there's any left over, I put it on the carbon. After spreading the 18 dots out in pairs on the oxygens, I've ran out of electrons. And so, as I talked about on the last slide, you want to double bond to the carbon by taking a pair from the oxygen. We want to make sure that everything has 8 valence electrons, because if you count, each oxygen has 6 dots plus a pair is 8, 6 dots plus a pair is 8, 6 dots plus a pair is 8, but carbon only has access to 6 electrons from the 3 bonds. So I take a pair off one of the oxygens and make a double bond. And when I do that, I satisfy the octet, or 8 electrons around each atom. Now the last thing I need to do with polyatomic ions is something kind of technical, but is definitely something that is required. You need to put the molecule in brackets like this, and then outside of the brackets you need to put the charge of the ion like this. Now the brackets and charge are only required for polyatomic ions. If you have a neutral molecule, you do not need to put the brackets on, but since this is a polyatomic, you do. If this was a quiz or test, I would take off ½ a point if you didn't include the brackets and the charge on your final structure. Well, that takes care of this video lesson. Thanks for watching.